Hello and welcome. Today I'm excited to demonstrate the Sacred Protocol Escrow. This is a Polkadot Asset Hub based smart contract project, and it implements a decentralized escrow system for social media interactions. So what Sacred Protocol solves is a fundamental problem in blockchain interactions. How do you safely transfer funds to someone based on their social media identity without requiring them to have a crypto wallet? Whether it's tipping content creators or paying bounties, this escrow system ensures that funds are secure until the intended recipient is ready to claim them. So in this demo, I'll walk you through the complete Sacred escrow workflow. We'll compile and deploy the contract on Polkadot Asset Hub testnet, and we'll interact with it using our CLI. And we'll cover creating a deposit, claiming it, creating a cryptographic attestation using EIP 712, and verifying transactions on the Polkadot Asset Hub testnet. There are also refund if the depositor hasn't claimed, if the recipient hasn't claimed the tip, and we'll go over some admin functions where we can set the fees and things like that. So let's dive in and see how it works. You can find the GitHub repo on the Sacred Protocol GitHub. We will clone the repo to start off and cd into the directory. We'll open the IDE here, and we'll start off with copying the ENB. We'll have the README here. And in the environment variables, we need to add the deployer private key. Here I am going to use the hard hat private key, so I don't have to blur anything. This is a known address. Please do not use this for production. I'm just using this here for ease of demoing. We'll run npm install to install the packages, and I will go back to the README. The fee here is the protocol fee when the relayer is sending the funds to the recipient. Right now it's set at 1%. There's a max of 10% in the contract, and the RPC endpoint for the Polkadot Asset Hub testnet. So here I've installed the dependencies, and I can run npm test, which will first compile the contract and run some sanity checks. If I want to deploy it on a local hard hat node, we're using hard hat here, I can run npx hard hat node to get the local node started, and to deploy on it, npm run deploy local, and this should deploy it on the local network. So that test has been successful. I have a contract address here. But now let's deploy it to the Polkadot Asset Hub testnet. So npm run deploy. Also, you have to make sure that your deployer private key has funds. Again, this is using the hard hat known accounts. These keys are publicly known, so do not use them. To fund them, you can use the faucet. There's a Polkadot Asset Hub faucet. These keys are actually already funded. So now if I run the deploy command, it will deploy it on the Asset Hub testnet, and we can check. There we go. The Sacred escrow has been deployed, and we have the contract address. We can actually double check this on the block explorer. So here it is, 23 seconds ago. Perfect. Let's try it out now. So now that the contract is deployed, let's use the command line interface tool that we also have on our GitHub. And this can go through a demonstration of interacting with the smart contract that we just deployed on the Polkadot Asset Hub testnet. And we'll be able to test a deposit, create attestations, and claim tips. So let me go back here and clone the repo. So now, in here, we can launch a bunch of commands. Again, I'm going to copy my env. Now, in this .env, we want to use the contract address that we just deployed. So I'll grab it here. And for my realer private key and the attester private key, I will reuse the same key that we have. The relayer is the one signing the transactions to send the payouts, and the attester is the one signing the transaction for the proof. So they can be different keys here. But for the purposes of the demo, I'm going to use the same key. So once you have the environment variables set, we can go ahead and install the packages. And now we can run through some tests. Let's start with a deposit. So I can copy this command here, and this basically says that we're making a deposit on platform ID 1, which is Twitter currently, and we have an ID for the recipient. Ideally, if this would be their Twitter ID, the amount that we're sending in native currency, and optionally, I can provide my identity as the depositor, and optionally add a content URL with some content that I want to make the tip to. So running this creates a deposit on the contract that is deployed. And while this is going, I'm going to scroll down to the commands using the env. If you go down in the README, there are also commands that use a flag-based system, but they're less user-friendly. So let's go with this here. So now my deposit has been submitted. This is the transaction hash, and I have the deposit ID here. And if we do want to check this deposit, I can run this command and change the ID. Here the ID is 1, so this is good. And we can see that claimed is false. You can also pass in the JSON flag and have a little bit more details on the deposit. And here you have the content, claimed is false. So this is still up for claiming as the recipient. Here, this is a separate function to create the proof, the attestation. And you'll see we have a signature. If I run this again, there's going to be a different signature, and I'll talk about why in a second. But the claim step will run we'll create the signature and then push it to the chain. And the reason why we need the nonce and the expiry is, and this is done when we're running just the attestation command, it's using the date and a random number for the nonce because it needs to be a unique number attached to the signature. Each signature has this nonce, and once a signature with a specific nonce is used on chain, it cannot be reused. and this prevents someone from intercepting a valid signature and replaying it multiple times. And if you're wondering about the expiry timestamp limits the time window for the signature validity. So how it works is that the signature includes the expiry, which right now is set as at 24 hours. And after this time, the signature becomes invalid and cannot be used. And this prevents all signatures from being used indefinitely if they haven't been used. This is part of the EIP 712 data type, and this is what makes it a little bit more secure. So running the claim command here on deposit number 1, the claim has been submitted. Now we can check if it's actually been claimed. You can see it is claimed, it's true. This transaction, again, with the transaction hash, you can take a look at it on the Block Explorer. And we can see here that it's been interacting with our contract here. And this was my deposit and my claim, 0.1. So yeah, this is a complete flow of the deposit and withdrawal. We can also test the refund function. If I go back and make a deposit here, as the depositor, you are able to refund your deposit if the recipient hasn't claimed it yet, and you have to do it from the same account that deposited it. So here I have deposit ID 2, and let me check that. It's not claimed yet, and as the depositor, I can run a refund command on deposit ID 2. And the refund has gone through. And there you go. We've made a deposit. We have created the signature and claimed a deposit. The signatures are using the EIP 712 pattern, and this has several benefits. It has a replay protection because you can't reuse the signatures. It's time bound. The intent is very clear. It specifies the payout address in the signature, and there's also a dispute resolution because of the timeline expiry date. And that concludes our demo of the Sacred Escrow smart contracts and the command line interface tool. I hope this walkthrough has given you valuable insights on how we've built a secure, decentralized escrow system for social media interactions on the Polkadot Asset Hub network. Now, while the CLI tool demonstrates the technical foundation, I will be doing a follow-up demo of our user interface soon, which makes these same operations accessible through a beautiful web interface. If you're curious and want to try it right now, you can check out our live app at polkadot.sacredprotocol.com. If you have any questions about the implementation or this Sacred Protocol project, you can reach out. Please don't hesitate. Thank you for your time, and until next time, bye.